Hello and welcome all. Here we are back again with another video. This time we're in section 7.6. This is page 8 of your Unit 7 notes packet. In this section, what we'll be doing is finding missing sides and angles in triangles. That means we're not just going to be looking at side lengths and angle measures, but we're going to be using trig for both of those. Let's start out in this first triangle here, where what I've started doing is labeling each of the angles. Now, I chose to do this because it's where my mind went first, but what you'll notice is that we're solving for an x, a y, and an angle here. So the first thing that I wanted to do is actually look at the insides of this triangle because I actually know 2 of the 3 angle measures inside the triangle. One of them is 90 degrees and the other is 21 degrees. So I know that together those make 111 of my 180 degrees. If 111 of the 180 degrees are taken up, that means that that final angle, or the third angle in that triangle, has to be an angle that measures 69 degrees total. So now when I think about theta, I have a 69 degree angle, or I have a 21 degree angle. I'll get to choose which angle I refer to as theta because now I know both of those angle measurements. And remember, the right angle will never be your theta. You will never reference that angle. So what I have to do now is I have to determine what am I going to choose as theta for the angle of reference that I'm given. Well, first, I'm going to go ahead and label my hypotenuse because that doesn't change based on my angle of reference. So before I choose a theta, I'm going to label the hypotenuse. And this is the variable x. So at some point, I'm going to have to use the hypotenuse to find the value of x because that is the length of the hypotenuse. Now I have to label my opposite and my adjacent. Generally, what I will do is I'm going to use theta as the angle of reference that I'm given. So if they already tell me in the problem what an angle is, that's usually the angle that I'm going to use. Now, you could have used the other angle as well, and you will get the exact same answer for x and y. It's just that your opposite and your adjacent sides are going to be a little bit different. So since I chose 21 degrees to be my angle of reference, I look at the hypotenuse and then the second side that actually make that angle. That second side is my adjacent side. So right now I have that the hypotenuse of this triangle is x. The adjacent side of the triangle measures 4.5, and that means that there's only one other side length here, and that has to be my opposite side. Y is the opposite side because it's the only side length that is not directly in contact with the angle of reference, which I chose to be 21 degrees. Now I have to solve for x and y, and there are a few ways that I can do this. I like to go alphabetically, so I'm going to solve for x first. That's the hypotenuse here, so I'm going to show my work out to the side. I'm going to show you first how to do this with trig, and then you do have options for how you solve for y. But to solve for x or y, whichever we choose first, you have to use trig. First, I'm going to identify that the hypotenuse is the value that I'm looking for. That's what I'm trying to solve. And then I know the value of the adjacent side. I don't actually know the length of the opposite side, so I can't use the opposite side if I'm trying to solve for the length of the hypotenuse. The only trig function that involves the adjacent and the hypotenuse is cosine. So instead of the cosine of theta, I want the cosine of 21. And instead of a over h, I want 4.5 over x. What I've done is taken the original cosine formula and I just plugged in all of the pieces of information that I know. Now I'm going to solve this equation like I would any other regular equation. If I want the variable by itself, I need to get it out of the denominator of this fraction. So I multiply by x on both sides of the equation. On the left-hand side, this is going to look a little bit weird, but x is being multiplied by the cosine of 21. On the right-hand side, when I multiplied by x, I did x divided by x, which canceled that out. So now the only thing that's left over is the 4.5. I'm really close to having the x by itself, but I have to get rid of this cosine of 21 because I just want the x all alone. So I have to divide by cosine of 21 on the left and the right hand side. This is where I need to make sure that my calculator is handy, but you can see that it is. So I have cosine of 21 divided by the cosine of 21 is 1. So on the left-hand side, I do have the x by itself. Then on the right-hand side, I have 4.5 being divided by the cosine of 21. This is what goes into my calculator, and this is how I'm going to be able to find the length of the hypotenuse in this triangle. I put this in, and I end up with 4.82. You can round that to 4.8 if you'd like to. That's where I'm going to stay, but if you want to keep it at 4.82, you're more than welcome to do that as well. That makes sense to me because a 21-degree angle isn't a very big angle. So that means that the length of y should be really short. Your adjacent side is 4.5 and your hypotenuse is 4.8. The hypotenuse is the longest side. So the longest side of your triangle has to be 4.8. That's really, really close to the length of your adjacent side. So when we solve for the opposite side length, I anticipate that being a pretty small number. If I want to solve for the opposite, first I have to use the opposite side. So I know that the opposite side is y. And then I actually have an option here. You could use the hypotenuse, 4.8, or you could use the adjacent side. I usually give whatever information I'm given, or use whatever information I'm given. So I'm going to use opposite and adjacent, and that's going to drive me to tangent. So the tangent of theta is the tangent of 21. And then the fraction opposite over adjacent is the fraction y over 4.5. I could have used sine if I wanted to, and then it would have been 4.8 and the y. You'll get the same answer. The rounding might be a little bit different. Now I'm going to do the same step I just did in the last problem. I have to get the y by itself. Right now it's being divided by 4.5. So in order to undo that division, I multiply. And of course, if I do it to one side, I have to do it to the other side. So now I can see what's ready to go into the calculator. I have 4.5 being multiplied by the tangent of 21. And then on the right-hand side, 4.5 divided by 4.5 is 1. So the y is by itself. This goes directly into a calculator. And if you're having any calculator problems, you can always let me know, and I'll try to help you however I can. And I get 1.727. I would keep that at 1.7. If you wanted to round it to 1.73, you're more than welcome to do that. But generally for a side length, I'm going to tell you to keep it to 1 decimal place. And for an angle measure, I'm going to suggest that you round it to the nearest whole degree. I just think that makes it a little bit easier to keep our numbers kind of in line. And if you had used 4.82 or 4.8 as your hypotenuse, you'd get pretty close to 1.7, but your rounding might be a little off. So keep that in mind.